Awesome. Okie dokie. Then great that you're all here. I don't know if there's an official moderator. If not, I'll just be the official moderator. So this is the talk of Jens and me, and I tricked you into coming because actually it's just my talk, and Jens is not going to say anything because he had to prepare his keynote. And this talk is going to be about one block to rule them all, and I'm going to talk about media computation. I'll let you know which one block is the block that rules it all, or which is the block that I like most and think is the block that rules it all, and then some demos on what to do with it. So here's the agenda. First of all, why do I want to present this and why do I want to talk about this? Then what is the mysterious block that rules them all? And then I want to do some demonstrations of power. Let's start here. Once upon a time, maybe we'll start a little later. Like 25 years later. This is me, 26 years old, an aspiring biologist who thinks that computer science is really boring and she never wants to program in her whole life. And then one day she meets Jens, and Jens is like, he's like, Jens, oh wow, have you heard about Snap? And then the first thing he basically told me is lambda calculus and how map works, and what's the awesome thing about it. And I go, okay, what is this guy talking about? I have no idea. Then he started with some easier things, and then he went back to lambda calculus. Like in our first meeting, he told me everything about continuations, and of course I forgot everything about it. But then at some point I was like, yeah, maybe let's give it a try. And I was experimenting a lot, and things that I personally found to be the most fun were stuff that had to do with data, that had to do with media, with sentences, with words, also a lot with pixels. I really like everything that has to do with pixels. So those were projects I tried, and those are also projects I want to show you that have to do with language. So the first one is an acronym generator that creates an acronym out of these words. The second one is the apps function over a set of samples that I made. And the last one doesn't actually use map. It's just something with pixels that I really like and looks beautiful. And then at some point, I grew really fond of it. And I can't stretch that enough. Understanding map was like one of the best experiences in my life. So I really, yeah, map, it's the best thing in the whole Snap thing, in the whole programming language, and also the block that I love the most, and that really got me excited about data science, about computer science. So yay, we are now all big snappers. I mean, Jens was before, and now I'm also a huge fan of Snap. Then I was asking around a little bit, and I was checking on Google, what is the one block to rule them all? What do people think is interesting in programming languages? Then I read a bunch of threads on Stack Overflow, and people were like, yeah, it might be loops, or it might be conditionals, or it might be whatever. But in our last SnapCon meeting, we kind of all agreed that it's definitely the rings in Snap, the part of Snap that makes or turns functions into data. And now I just want to show you some examples of stuff that you can do with it. And we start with media, with different forms of media and easy lists. So let's go to the presentation mode or the demo mode. Here we go. I already used the new Snap feature, but maybe I turn it off so you can see the blocks better. Okie dokie. So the first thing I wanted to show you is how you can do the usual Caesar cipher in Snap using the map block. So it's basically something Jens has shown you today already in a much shorter and probably a little cooler form, but we're going to do it anyway because I wanted to focus on the whole show something with text, show something with sounds, show something with pixels. Yeah, triangle that we came up with. So for the text, we're going to do the Caesar cipher, and I'm going to create a text for it. Let's do a variable first for it, which I call text. And this text is going to be, wait. Let's do I love Snap. here's my variable. And now I want to apply a function in it. So this function is going to be, first I want to transform all of my letters into their specific Unicodes. Then I want to add a number to that Unicode, my key, and then I want to give back or give out that Unicode as a letter again. So I shift all my letters by the key. How can we do that? First of all, we need to grab the Unicode block from the operators category. We need both of them. And as I mentioned, we also need a plus block. So what we want to do is we want to get the Unicode of a letter. Then we want to add a specific number to that. Let's do it. I think I read somewhere that Caesar usually used 3. So let's do 3. And then I read somewhere else that Caesar was not actually using that cipher. So I don't know, but we'll do 3 anyway. And then we want to report that back as a letter again. Let's try it with A. So Unicode of A would be 97. So what I would be expecting is that I get a 100 if I execute that function. That works. And that I get back the letter plus 3, which would be a D. That works as well. So how can we apply that to all our letters in our text? First of all, we need to grab the map block, which is in the lists category and is a higher order function, which you can recognize by the gray ring. That means that it takes a function as an input here, which I guess most of you know. So I can put my function in here and I can leave that first input slot empty. And then as a second step, I need a list in that second input slot, and I already have something that I can turn into a list, and it's my text. So I want to grab the split block to actually make a list out of it, because right now it's a string. And if I split it by letter, I can make it a list. And now I can add that here. And now I can transform my text. The problem is usually you skip the spaces because you can easily recognize the spaces. And also you usually only write capital letters or only lowercase letters because you can see the beginning of words. But anyway, I only need this one expression to create a Caesar cipher. We can also join it together again. Then it's one more block, but still pretty cool. To get back my ciphered text. And to decipher it, I could just use the exact same expression, just the other way around. I changed those 3 here and just do the 3 blocks here and just do -3 in the middle. So I get back the original block. So that's pretty easy if you want to get started with text. And then you can also use the exact same thing to, for example, create secret languages where you change specific letters or where you add stuff to specific letters. And that's always pretty fun lessons when we do that with kids. So I highly recommend that. And I also saw in the chat of the keynote that a lot of people are doing Caesar cipher already. So keep doing it. It's also great fun with map without the hyperblocks. And as a second thing, I wanted to show you something with sounds, because text is a one-dimensional list. It's just a little list of letters. When you record sounds in Snap, and let me create a new project for that. And let me record something or wait until the trams past our house. So let me first record a sound. Snap. Okay, did that work? Okay, let's try it again. Snap. Okay, great. Let's use the second one and let's throw this one away. So here we have our snap sound. It's called recording 2, but I can rename it to snap. And now we can explore that sound with a block from the sound category. And it's this duration of sound block. And I can select my sound in here, which is called snap. And then I can find out different things about my sound. For example, its name, which is snap. So that's kind of boring. Its duration, which is 2.64 seconds. And other things like, for example, its samples. The samples is kind of long list with 42,240 elements. A lot of them are zeros, and then at some point I get to numbers which are pretty small. So here, for example, I have a 2.2, and then I have a -4 and 8 and whatever. So the samples tell me in which direction and how far a membrane, for example, in my ear or in the speakers in my computer swings, and the amount of that swing is a sample. And a lot of samples make up a sound. So I can now do stuff with this sound. For example, I could use a function on it with the map block. Let's grab the map block again, and let's do an easy one first. So for example, we could do the, Jens, how can I get my audio to transmit to Zoom?
Okay, you probably have to unshare again and share, and then hit there's a checkbox.
Okay, wait, then I'll
audio.
stop sharing, and then we'll do that again. Okay, share screen, and then share computer sound. Awesome.
Yep, that's the trick.
Okay. There we go. Awesome. So maybe can you turn the volume, your volumes down a little bit? I will just try this out with the play sound. Be careful. Snap. Okay, that's kind of okay. Great. So now we can operate stuff on our sound or apply functions to our sound. Let's try something easy. As I mentioned, for example, we can, what did you do? The abs function, right? Let's do the abs function. Let's see what happens. So we only want to get absolute values, that we don't have negative values anymore. And we want to get the absolute values of each specific sample. And then we want to play that sound. Let's try that. That's interesting. So we changed our sound. This should give us the original sound, right? Why is this so high, Jens? Why is the pitch so high?
That's a good question. I have no idea. It must have something to do with sharing the audio, probably, right?
Okay, that's interesting.
Maybe you just record it again, because I'm pretty sure it just changed the sampling rate.
The sampling rate. Okay, then let's try it again, and let's record another sound. Wait. Snap. Snap. Okay, let's try. Oh, we can wait. We can check the sampling rate of this one. It's 16,000, and we can change the sampling rate of this one. But this also 16,000, so that shouldn't make a difference.
Well, maybe it's not actually the sampling rate. Maybe it just changed. I don't know.
Wait. Okay, let me check this for a second. Does this change something? Snap. Let's do the usual. Okay, maybe this block just uses 44,100 hertz.
No,
okay.
it actually should use whatever
the sampling rate is, right?
Try the new sound. It should come out all right now.
The recording?
Yeah.
But that's the actual sound.
But it should be in the regular block also.
Let's try it.
It's not the sample rate, it's the...
Right, sorry, it's the samples. Okie dokie, let's try it again. Nope, let's try it here. That's actually what I wanted. Let's throw away this one. Let's just use 16,000 hertz. Maybe that has to do with the sampling rate.
Interesting, it has something to do with Zoom.
Anyway, so the sampling rate is the number of samples I get in 1 second when I record the sound, and the playback rate is the number of samples I get in 1 second when I play it back. And if they differ, you get a different pitch. So apparently the usual or the regular play sound block has a different playback rate than my sampling rate. So the sound changes. Let's do the same here. And now if I use the abs function again, let me click on it. I kind of get a noisy and nosy sound. That's what we wanted, but that's a intermediately interesting function. the one that I wanted to show you is the idea is that we want to average two samples. For example, the sample that we're currently looking at and the one 500 samples back. And how can we do that? Let's first create an average block for that. And this average block is taking a number and it's average, we do average the number 1 and the number 2. And number 1 is going to be an input and number 2 is also going to be an input. Here's our block, and if I input 1 and 3 here, I want to report it. I wanted to report 2. Right now it doesn't report anything, so let's create an actual function. The function is supposed to add number 1 and number 2, and then it's supposed to divide them. So that's sum by 2 again. Let's click apply again. Let's try it. Reports 2. Awesome, that's what we want. So right now we want to take the average of our sample and a sample way back. The problem is if I only have those empty input slots, I cannot get another sample than my actual sample that I'm just looking at. So what we can do to also get information about other samples, about the index of a sample in a list that we're currently looking at, or about the list itself, we can expand that gray ring by clicking on it 3 times. We get explicit parameters there then. So the first one is the actual value that we're currently looking at. That's basically the same then if I just use the empty input slot. If I click on it again, I'm getting the second one, which is the index. So this is the index of the value I'm currently looking at. And the third one is the list itself. So what we want to do right now is we want to average our current value and then the value of 500 samples before, or maybe let's do 1000 samples before. So we grab the item and the index, but we want to use the index, for example, minus 1000. And we want that to be from our actual list of samples. So I will just click on it and we check what happens. Snap. Maybe we'll increase that number here even a little bit. Snap. And you can see that we just created ourselves a little echo effect, which is kind of cool. So I only need to use the list and those 3 blocks that I used to create that average function to have an echo effect for all my sounds that I ever created. It doesn't really work on songs that well, so you basically need stuff that doesn't have too many instruments and also has pauses sometimes in between, so you can actually hear the echo and not just make your sound pretty bad. But that's kind of cool, and it's still just a one-dimensional list that we're working on. Okay, so I'm kind of running out of time, but I want to show you the pixel stuff real quick. And too bad I didn't prepare a data project, but I was kind of sure that we wouldn't make it to the data part anyway, or the plain data part. This is all data that we're looking at here. So let's do the stuff with pixels again. I'll just recreate a screenshot of my face real quick. This is me. And like with the sounds, in the sounds category, we also have a block to explore images in the looks category. It's that width of costume block. And I can select here my camera costume or my current costume. Let's take the current. Then I can find out stuff. For example, its width, which is right now the width of the stage. So it should be 480, or its height, or the pixels that I have here. And this is a list of 172,800 pixels, or basically it's a table in which every entry is a pixel that has 4 elements itself. And as you all know, pixels are made of RGB color channels and an alpha channel, which regulates the transparency of a pixel. So the first column is the red channel, the second column is the green channel, and the third column is the blue channel, and then I have the alpha channel. And this is just a list of lists, so I can, bam, use map on it and do stuff with it. Let's grab the map block, and let me tell you what I want to do. So we want to create a posterized effect, which means that we want to find out which parts of our pixel of our image are bright and which part of our image is dark. And then we want to just report back 3 colors, and we want to change our image so it only has 3 colors left based on the brightness, or let's do the greenness because that's faster, of a specific pixel. So I can grab the reporter if for that, but you can also drop the regular if in here if you want. So that works as well. And we want to use the pixels of our costume for that. And if, for example, the green channel of a pixel that we have here is greater than a specific number, then item, the green channel is the second one, right? Item 2 of the pixel I'm currently looking at is greater than, so 0 is the lowest number, 255 is the highest number. Maybe let's try 150. This needs a lot of tweaking because it's kind of dark here. So then we want to report a list with a specific number or with a specific color. And we can do that by just reporting back a list that has the structure of a pixel. The last channel is supposed to be 255. And then let's make that pixel yellow. So I want 255 in the first channel, the red one, 255 in the second, the green one, and a 0 in the blue channel. If that is not the case, so my pixel is not, or my green channel is not greater than 150, I want to put another if in here. And I want item B2 to be, let's say, greater than 80. And if that's the case, I want to report, let's do blue. So 255 in the third channel, and then 0 in the first, and 0 in the second. Else, I just, else I want to report red. So 255. 0, 0. Okay, let's try that. If I click on it, it's running. This takes quite a while because I'm running it over the 172,800 pixel. And now you can see that I only have, basically I only have 1 color left. Here's another pixel. Here's one that's different again. So you can see that we only have 3 colors left. And now let's try that. And then we maybe have to tweak the colors again. You can also add just a number of pixels to the regular switch costume block, and then it will put on those pixels. So I can just drop my list in here and can now tell it to switch to that costume. And now let's check how it looks. It's probably pretty, no, maybe we want a little more yellow. Let's do 220 here, and let's do 70 here. And let's try it again on the camera costume. Nah. Okay, it works better when your image has a greater, wait, let me just turn on the light for a second. Maybe we can try it with another photo. Wait, one last try, and if not, I'm done and ready for your questions. Okie dokie. Let's try that again.
No, you have to say camera 2.
You're so right. Bam. Yeah, awesome. Okay, so thanks for your attention. What I wanted to say as final words is, what I really love about it is that you basically have the exact same functions and you can apply them on text. You can apply them on sounds. You can apply them on pixels, and you can basically apply them on any kind of data that you want. And that's just awesome. Thank you. Questions?
Hi, question. So I had a question on the sound manipulation. I know, so Jens earlier did the Pink Floyd thing, and it imported in the sample as a stereo file. When we play the sound block back, does it play in mono, or does it actually try to process both left and right channels separately?
That's
I
where
can
Jens
answer
was on the
that.
talk. Yeah.
It actually, if you play back, it actually turns it into a stereo sound. It actually plays back stereo. So you can make your own effects by stitching together something different on the kind of one channel and on the other channel. Yeah.
Okay.
So what we do is when we record sounds, we force them to be mono, and we actually take some effort because that's when we can just directly go down to the samples and do the interesting stuff. But when you import something, you know, from a commercial album, it's usually it has more than one channel.
Okay, thank you.
Okie dokie. Any more questions? I think we have like 3 minutes left. But if you come up with questions later, I'm also sticking around.
We have some questions in the chat.
Yeah. Are there some interesting ways of getting data that are easy already in Snap, for example, gather data? You can actually just drop spreadsheets into Snap. So I didn't, as I mentioned, I didn't get around to present that now. But for example, I'm I'm playing in a Dungeons and Dragons group, and last time I made a project about spells that you can learn in Dungeons and Dragons, and then we did some filtering. This is actually also the video that we do for filtering in our OpenSAP course, and then you can just drop that in here, and it also automatically passes CSVs and JSONs, and you can then just apply the stuff on data. And there's also a pretty great resource which is called Corgis. It's something like great curated data sets, and you can find curated data sets there, for example, about the billionaires of the world or about the gross income product and stuff. So that's kind of interesting as well, and it works pretty cool. What I don't like about the general data analysis thing is that mostly you need to kind of dig deep to get to the actual numbers that you want to look at. So in JSONs, you basically wrap the item off and map over, and item off block and map over block into each other until you finally get down to the numbers that you actually want to look at. But if you find, or if you manage to get easy or simple lists or tables, it's great fun to like do stuff with. I don't know, what I also really like is implementing your own statistical blocks. So for example, your own average block, find the median, sort data, calculate the standard deviation, because it's really fun implementing them and then seeing how good your data actually is. So that works great also in workshops.
I had a question about videos, yet another kind of media besides sound and images. And presumably you could get the list of the pixels. So it's a list of lists of pixels, red, green, blue. You could do the same kind of maps over maps. But is that actually a practical thing to do and then playing it back, or is it just going to be way too slow or memory intensive?
It works. It basically works on live video, on the live video feature of Snap if you run it with the compile block. So there's a way to compile the map block so it runs really fast, and it actually can break then. But if you tested before with the slow map, you can also run it or apply the stuff on the video feature on the stage. And that works kind of smoothly. It depends on how complicated your function is, of course, but just color switching or distorting pixels and stuff, that works really great on the live video.
When you're working with a list of audio samples, does the sample list contain information on the sample rate, or do you need to manually specify that like you did here?
Usually I thought it, so this never happened before. Usually you can, so the samples, if you take the duration of sound block, this also has an input for the sampling rate, and you can use that. So each sound that I record also carries its sampling rate around with it.
Yeah, but Dylan, like if you're just not encoding it as a sound, but just using a list of numbers to play it back,
Then
it just assumes that whatever is your default, whatever your computer thinks is the sampling rate, this should be it. And now, mind you, this whole multimedia web API is not the most stable. So it tries to do the right thing, but as we've seen, it sometimes doesn't. And I guess it depends, like, for example, when you reload the page, for example, when Zoom is on or something. But usually it'll just kind of use your default sampling rate.
Okay, then again, thanks for your attention. I don't want to steal any more time from the next person, but I'll be around if you have any more questions.
Maybe we should applaud.
Yeah, feel free to applaud. Thanks.